All right, now we are actually going to go in and do the same exact thing for looking at headers, but actually do everything in Wireshark. I'll see you over in Wireshark. All right, now that we are in Wireshark, let's talk about the first header that we talked about, which was our Ethernet header. Remember, we tip before we sip, so this is our target MAC address, aka our destination MAC address, taking up the first 6 bytes. We have our source MAC address taking up the next 6 bytes, and at the end of the Ethernet header, we have telling us what's coming next for 86 delta delta, telling us IP version 6 is coming up next. If we had 0800, that would be IP version 4, and if we had 0806, that would be ARP. The next header that we looked at was a ARP header. We can close out of our Ethernet header and highlight the ARP header here. So we had our hardware type being denoted as the first 2 bytes, so 0001 gave us Ethernet. The protocol type taking up the next 2 bytes, 0800, giving us IP version 4. The next byte, hardware size of 6. The next byte, protocol size of 04. An opcode taking up the next 2 bytes. Our sender MAC address taking up the next 6 bytes. Our sender IP address, again calling out C08A as 192.168. The target MAC address, all zeros here. And the target IP address or destination IP address, we see C08A again for 192.168, 1, and then delta 6 converts over from hex to a decimal value of 214. All right, the next header that we had was our IP version 4 header. We can break this one down. Again, 0800 telling us from our Ethernet header that IP version 4 is next. The version is 4. The actual length taking up the next 4 bits there. So the 5 times 4 gives us 20. Different services. The total length taking up the next 2 bytes. Identification section taking up the next 2 bytes. The flags for don't fragment. The fragment offset set to 0. Time to live, we talked about our common TTL values of 80 in hexadecimal, giving us 128, 40, giving us 64, FF of 255. Protocol, is it going to be TCP or UDP header coming next? Hexadecimal value of 06 means TCP is inbound. If it was 11 in hex, that would be 17 in decimal, meaning UDP would be the next header. Our checksum that comes in, C08A, our source address, 192.168.1.168, and our destination MAC address, or our destination IP address, 192.168.1.238. The next header that we looked at was our IP version 6 header. You can drop this one down. We're coming off our Ethernet header for the value of 86 delta delta, meaning that the next header coming in is IP version 6. We have the version telling us it's 6 with the traffic class denoted all by zeros. Flow label also zeroed out. Payload length 22 in hex becomes 34 in decimal. We see not a 06 this time for TCP, but a 11 in hex, which is a decimal value of 17 for UDP. As you can see, the UDP header is inbound next. The hop limit, 58. Source address, remember this massive 16-byte, 128-bit IP address for IP version 6. So this is our source IP address, followed by the next 16 bytes, 128 bits for our destination IP address. All right, The next one we covered was ICMP. We see we had an Ethernet header coming in, ending in 0800, telling us IP version 4 was next. We have this easy spot out here for version 4 with the default length of 20 bytes. If we went a full 20 bytes, that is where the IP version 4 header ends and the ICMP header begins. We have our type and code messages taking up the first 2 bytes. So the first byte is for type. We have a 08, an echo ping request. If it was a reply, you can just change it over one really quick. We have 00, the reply being 00, the request, if you can see it changing over to type 8, code 0. We had our checksum taking up the next 2 bytes. The next 2 bytes was our identifier, and the rest of the packet I really said I didn't care much about. And you have your sequence number, and then the rest of the payload of the data that's actually coming over being variable in length, and in this one it is 32 bytes. Most important thing, recognizing our type and code message for our ICMP. This is a 80 for request, a reply, a ping reply being a 00. All right, we had our TCP header next. As you can see, the end of our Ethernet header, the 0800, telling us that IP version 4 is coming next. Version 4, default length of 20 bytes, 816, and we have 2 over here, and then 2 up here for 17, 18, 19, and 20, splitting it up and counting it a lot easier. Going into our TCP, we see our value of 6 there, telling us that the protocol TCP is next. 11 would have been UDP. Breaking down our TCP header, we had the source port take up the first 2 bytes and the destination port take up the next 2 bytes. Remember, the server always has the lower port value, so this is a server packet. If we go to the next one, this is a client packet, as the source port is the random high port assigned, and this packet is going to the destination that has the lower port value, so that means it is going to the server. Going back to our other packet here. Segment length can go into the sequence number that you would have, and it gives it to you the raw value in Wireshark. Your acknowledgement number taking up the next 4 bytes. Header length, 5 times 4 gives us 20. And the most important section are our flags. It's always going to be taking up the last bit here, not counting the 5. Let's get our flags highlighted. The 010, again, going to be an ACK with each bit being allocated to a different value for what flags can be set. Window taking up the next 2 bytes. The checksum taking up the next 2 bytes, and the urgent pointer taking up the last 2 bytes. And our UDP header was the last one that we covered, rolling off our Ethernet 86DD, telling us we have IP version 6 as the next header, version of 6, rolling into UDP. You can find the 11 right there for the next header, going to be UDP. Dropping down on our UDP header, we're starting with the first 2 bytes as our source port, the destination port as the next 2 bytes. So this is the server packet as the lower port number is here. The length taking up the next 2 bytes. So 21 in hexadecimal is a length of 33. Checksum taking up the next 2 bytes. And the rest is really just reserved for a bunch of data. So 25 bytes worth of data actually being sent in this packet. I give you a lot of credit for making it through the header analysis. It's a lot of information. It's very challenging. And if you can absorb 20% of this, I would be ecstatic. So thank you.